A particle is travelling in a straight line. After 4 seconds, the particle has a velocity of -9 meters per second. The acceleration a meters per second after t seconds is given by the equation a of t is equal to -6t plus 12. For part A, we're asked to find an expression for the velocity of the particle v of t. So the velocity of a particle is equal to the antiderivative of the acceleration of the particle, and we anti-differentiate that with respect to t. Therefore, our expression v of t is equal to the antiderivative of -6t plus 12 with respect to t. And to anti-differentiate that, we simply add 1 to the power and divide by the new power. So we're going to have -6t, and it's going to become t squared divided by 2, plus 12, which is the constant. And wherever there's a constant, when we anti-differentiate that, we introduce the variable t, or whatever we're anti-differentiating with respect to. And then we get plus c, where this is the constant of integration, and that means it's an element of the real number set. We can simplify this down slightly, so -6 divided by 2 is -3t squared, plus 12t plus c. And then we know that after 4 seconds, the particle has a velocity of -9 meters per second. Therefore, when we evaluate the velocity at t equals 4, it's going to equal -9, which gives us the equation -3 times 4 squared, so just the velocity with 4 substituted in for t, plus 12 times 4 plus c must equal -9. And when you solve that equation, you actually find that c equals -9. Therefore, we find that our v of t, our expression for the velocity, is equal to -3t squared plus 12t minus 9. For part B, we're asked to sketch the graph of v of t for t greater than or equal to 0, clearly label any axial intercepts, endpoints and turning points with their coordinates. So to start off with, we're going to find the y-intercept of this graph, and we do that by letting x equal 0 in the equation. So the velocity evaluated at 0 is going to equal -3 times 0 squared plus 12 times 0 minus 9, which simply equals -9. Therefore, we have the coordinate 0, -9 as the y-intercept. Next, we're going to find the x-intercepts of the graph by letting y equal 0. So that means we're solving the equation 0 is equal to -3t squared plus 12t minus 9. And to solve this quadratic by hand, we're going to first factorize it and then use the null factor law. So the first thing we can take out is a highest common factor. So we can solve 0 is equal to, and we'll take -3 out, leaving behind t squared minus 4t plus 3. Then we can factorize this further by inspection. So we'll have -3, and then we can separate this into two linear factors. And we look for the factors of +3 that add up to give -4. So we can have t minus 1 and t minus 3 as being those two numbers. Using the null factor law, we find that t minus 1 could equal 0, or we could have t minus 3 is equal to 0. By adding 1 to both sides of this equation, we find that t is equal to 1, and adding 3 to both sides of this equation gives t is equal to +3, meaning the coordinates of the x-intercepts are 1, 0 and 3, 0. Finally, we also need to find the turning point. And we know that the turning point will occur halfway between the x or t intercepts, so that means it will occur at t equals 2. Therefore, we are in fact evaluating v of 2 is equal to -3 times 2 squared plus 12 times 2 minus 9, and that will help us to find the y value. And when we evaluate that, we find that that's -3 times 4 is -12 plus 24 minus 9, and that equals 3. Therefore, our coordinate of the turning point is 2, 3. So taking into account all of that information that we've just found, and the fact that we have a negative out the front of the t squared term, which means it's going to be a parabola in that shape, we can now sketch the graph of the velocity curve. So we know we have a y or v-intercept of -9, and then a parabola that has this shape. So we can now label the key features, which is going to be 0, -9, One of the t-intercepts is going to be 1, 0. The other t-intercept is going to be 3, 0. And the turning point is going to be at 2, 3. The last thing we're going to do is just make sure we've got some scales on our axes. So this is going to be t equals 2. This will be v equals 3. This will be v equals -9. And this is at 0. So that is the finished graph for part B. For part C, we're asked to determine the distance travelled by the particle in the first 3 seconds. So we need to remember that the distance travelled is given by the area under the velocity curve. So that means that for this question, the distance is equal to this area here in red. And because it's below the axis, we're going to introduce a negative symbol to make it positive. So it's going to be the area is equal to negative times the integral of 0, the bottom x value, to 1, which is the top x value, for v of t dt. And then we're going to add on the area under the curve for the next part, which is going to be adding on the integral between 1 and 3 of v of t dt. So when we add these two things together, we'll get the total area under the curve, and that will give us the distance travelled. So this is going to be equal to, and in square brackets we have our antiderivative, so minus 3t squared when we add 1 to the power and divide by the new power is simply going to be negative t cubed, and then plus 12t and add 1 to the power and divide by the new power is going to give plus 6t squared, and then we're going to have minus 9t, and that's evaluated between 0 and 1, and we still have a negative symbol out the front to make that value positive. And then we're going to add on the same antiderivative, which is minus t cubed plus 6t squared minus 9t, and we're going to evaluate that between 1 and 3 for the second area that we need. So our distance is going to equal, and in red we're going to have negative, and then we're going to do capital F of 1, which is the antiderivative evaluated at 1, subtract the antiderivative evaluated at 0, and then we're going to add on the antiderivative evaluated at 3, subtract the antiderivative evaluated at 1, and that will give us the area under this curve, and that will be equal to, and we shouldn't forget that negative symbol out the front, and then for f of 1 we'd have negative 1 cubed, which is just negative 1, then we'd have plus 6 minus 9, and then we subtract away that, the antiderivative evaluated at 0, which is simply subtract 0, and then we add on to that the part in green, so we're going to have capital F, the antiderivative evaluated at 3 first, so if we put 3 into there we get minus 27, then we have plus 6 times 9, which is plus 54, and then we have minus 9 times 3, which is minus 27, and then we subtract away that f evaluated at 1, which we found before was negative 1 plus 6 minus 9, so that is the area under the curve for the negative and positive regions of area. And then our job is just to clean this up a little bit. So in the red we're still going to have negative, and then we have negative 1 plus 6 minus 9 is negative 4, take 0 is just negative 4, and then we have plus, and then we have negative 27 plus 54 minus 27, so that whole bracket is simply 0, so we're just going to have plus negative 4 again. So evaluating that, we have positive 4 plus positive 4 equals 8, which means that the particle has travelled 8 meters. And that is the distance travelled in the first 3 seconds of its journey. For part D, we're told that the initial position of the particle is 4 meters to the right of some origin O. For part 1 of this question, we need to determine an expression for the position of the particle x of t. So first of all, we need to remember that x of t, the position or displacement of a particle, is equal to the integral or antiderivative of the velocity, and that's with respect to t. Therefore, x of t is equal to the integral, and our velocity was minus 3t squared plus 12t minus 9 dt. And we did this in the previous part of this question where we added 1 to the power to get minus 3t cubed divided by 3 just gives minus t cubed, plus, and then it's 12t squared over 2, which is plus 6t squared, minus 9t, and this time we're going to add on the constant of integration, where that c is an element of the real number set. Now we know that initially it's 4 meters to the right, so that means that x of 0, that's the initial position, is equal to positive 4. Therefore, we find that our equation can become minus 0 cubed, so we sub in 0 wherever there's a t, plus 6 times 0 squared, minus 9 times 0 plus c is equal to 4, and that will give us c equals 4. So overall, we find that our position, x of t, can be written as minus t cubed plus 6t squared minus 9t plus 4. For part 2, we're asked to calculate the displacement or position of the particle after 5 seconds. So that means we want to evaluate the position rule when t equals 5. And when we put that in, we find that it's minus 5 cubed plus 6 times 5 squared minus 9 times 5 plus 4. And cleaning that up, this is minus 5 cubed is minus 125. And then plus 6 times 25 gives plus 150. Minus 9 times 5 is minus 45 plus 4. And when we evaluate that, we find that that is equal to negative 16. Therefore, it is 16 meters to the left of the origin.